So let's get started, shall we? Okay, so this week it's finally here. Yay, character rigging, okay? I know a lot of you guys have been waiting impatiently for this moment. We're going to start the process of understanding how to put a character rig together today. This is going to be a multi-week kind of sequence that we're going to go through, because as one might imagine, getting everything hooked in and wired together correctly takes some energy, okay? And we're going to start with a really good, basic, solid, foundation level understanding of what it is that we're here to produce, okay? Before we go any further, I am not a character rigging super expert, okay? I like to kind of set that expectation going, on day one. I don't know everything about character rigging. It's not what I do for a living, but I know the basics of it. And I have a really, really good, solid understanding of what the computer is. I'm like an intermediate level character rigger, okay?
Level 35 rigger.
Yeah, I'm not a level 35 rigger. There are super ninjas out there where that's all they do. Let me see if I can show you guys if it's even here anymore. They have the ball man anymore? Maybe. Looks like they taken ball guy out. That's a bummer. There used to be, as part of the Luxology content, a fantastic rig from one of the developers for Moto, who actually is a full-time character artist and character rigger at Pixar. His name is Rich Hurry. Actually saw Rich Hurry's name in the credits at Cars 3 over the summer, which I thought was really kind of cool. We were packing up our gear as we were heading out, my family and I, and just happened to glance up at the screen to catch Rich Hurry's name going up the credits. I was like, oh, I know that guy. Anyways, it was kind of cool. He had a fantastic rig that he included in the Moto kind of asset bundle that was just amazing. In every sense, it kind of showed how far you can go with the rigging stuff inside of Moto, and it was a mad scientist's kind of rig. It was pretty neat. It was just a simple ball that had eyes and a mouth on it, and it did like automatic squash and stretch and deformation as it hit the ground plane. I mean, everything had these really crazy level of controls on them. The conversation about character rigging can go very, very deep. Okay, did you guys see Finding Dory? Yeah, good film. Yeah, I liked Finding Dory. It was a lot of fun. Kind of lived in the specter of Finding Nemo. Kind of felt it's like The Force Awakens. It's like I kind of feel as though I've seen this film before, right? But it was different enough to make it unique. One of the biggest challenges on that film was Hank. You guys remember who Hank was?
The octopus.
Who was Hank? The octopus, who kind of stole the show, right? It was all about Hank, and in the behind-the-scenes featurettes, they actually had a little vignette on Hank, and they specifically talked about the character rigging on Hank themselves, right? Because think about an octopus. That is probably the most organic, the organic shape in nature, right? It is basically just this really wobbly, gelatinous sack with arms, right? These tentacles that can also squash and stretch, and I mean, it's crazy, yeah. Yeah, it did, and I think that's where I was going with this. The rig, the process of getting Hank to work correctly, not the sculpture, not the model, mind you. That was a relatively easy task to do, because an octopus, that's, I could do that in about 20 minutes, right? But the rig, the animation controls for Hank, they said it took them 2 years to figure out. Isn't that crazy?
I thought it was 3.
Yeah, and it went through like all of the character riggers in the studio, right? I mean, everyone's like, I can't do this, right? I give up. Okay, it's on to you. Let's see if you can figure out how to do this, right? So this conversation about character rigging can get really intense, okay? I'm not saying this to scare you away, but when you get out there in the real world, this is an exclusive job title for folks. There are super ninjas where all they do, and I mean all they do, is character rigging. They don't make the characters. They don't animate anything. They just create the internal machine that makes these characters deform and move, okay? Our little module here is going to give you a really nice understanding of what that character rigging process is like, okay? It's going to build off of some very important ideas that we've already discussed and established when it comes to constraints, creating locators, positioning things accurately within inside of a given rig. Those are all ideas that I intentionally put before this so we have a nice little foundation that we can build upon. The new thing that we're going to focus our energy kind of right now is on the creation of deformers and talk about what a deformer is. Kind of a new word for us. We haven't really looked at deformers, but on the on kind of the technical side, character rigging is all about creating deformers. Okay, a deformer is nothing more than a whole series of rules that takes a hollow mesh like our little green guy, which I can see a number of you guys have already downloaded, and to bend it along very specific axes and very specific locations. Okay, a deformer is just supposed to bend a mesh. That's all it's really trying to do, but in really fancy kind of technology. Let's spend some time looking at what a deformer is, how we can create them, and how we can continue to go in and manipulate our deformers to get a very predictable result. This is going to lead us into our conversation about paint weights. Okay, the character rigging process, the process of putting a skeleton in is pretty easy actually, and I think you guys are going to see that it's pretty straightforward. Where it gets really crazy and difficult is managing our deformers and doing all the paint weighting and getting our character to bend and deform the way we want it to. That's where it gets to be kind of a technical art almost, right? FYI, if you can find a good rigger, you pay that person as much as you can on your team, because good character artists, or excuse me, good character, like technical directors as they're called, are few and far between. When I worked at MTV, we had a woman on our crew that she was our technical director, and all she did morning, noon, and night was to do the character rigs for about a cast of almost 50 different characters, and that's all. Every time I looked over at her machine, she was just painting skin weights. That's all she was doing and managing her deformers, and she had it down to an art, right? And we made sure that she was very happy, because not everyone's a character rigger, right? And you even heard our presenter talk about that earlier. It's important that we're exposed to all these other facets of our larger animation industry, right? You don't have to be a super ninja in this one, and it's okay to hate it. It really is. But at the very least, you should understand it and respect its role in the larger context of what we're trying to produce. Okay? There are some portions of our 3D pipeline that I hate. Like, I just don't want to do them at all. It's like foliage. I don't want to do that, right? That is the most uncreative thing for me personally, right? I don't want to do plants and trees. That's just not how my brain thinks, right? I'm going to find someone who does plants and trees better than me, okay? All right, let's jump in and start making some deformers and start bending some things, okay? We're actually not going to start with the green guy. So if you have the green guy already on your screen, just go ahead and create a new project file. And what we're going to do, unsurprisingly, is start with a cylinder, okay? It's a simple unit primitive cylinder. Okay, let's jump in. I'm just going to hold down the good old control key while I click on the cylinder tool, and then, there it is. There it is, my lovely cylinder. Now, we're going to ask the computer to bend this cylinder, okay? What we don't want to do is have to go in and hand manipulate each individual edge or vert or polygon. Those days are gone. We want global deformers that are going to bend and change the shape of our mesh for us automatically, right? At the end of the day, we want this rig to be the driver of the deformation, not our own personal ability to select a bazillion little edges. I'm sure you guys have done this manually, and especially if you've taken 402, right? In order to bend this cylinder, you have to go in, select edge loops, maybe rotate a whole bunch of them. It turns into a process, right? So let's use some deformers to help us start bending this a little bit more intelligently, or just manipulating it the way we want it to manipulate. Okay, so as one might imagine, we're going to be doing a majority of our work today and our understanding of how deformers work in the Setup tab. Okay, there we go. So this is where we saw this with our constraints. You can't escape the Setup tab for the next 6 weeks. Okay. I hope you had fun in the animation portion of your Alien Invasion project, because that was, it's all setup stuff here for a bit. If you look very carefully over in your toolbar, you'll see there's an entire Deformers section, okay? So these are all of our Deformer tools, okay? Now, Deformers are always applied to an object, okay? or excuse me, to an item inside of our scene. We can ask the computer to do this automatically for us, to automatically apply a deformer to a selected object, or selected item, excuse me, or we can have the computer influence many objects from a single deformer, okay? The power of the schematic allows us to send this deformation material to many, many different things all at once. It's pretty neat, okay? Let's start off by just doing some simple deformation of our little cylinder here. Now, the easiest way to get this to work correctly, believe it or not, is to not apply the deformers in this list, although that will work, okay? Here's the best way to really make sure that everything gets wired together immediately, okay? Go over to your item list, okay? This is Pat's little hidden trick of the day. I'm just going to name this cylinder, if I can spell correctly. There we go. If you right-click on it, check it out. We have Add Mesh Operation, okay? This Add Mesh Operation command is going to pull up this little browser, okay? And you can even, I want to move it away from my item list so we can see both at the same time. And where we're going to go is this Deformers category inside of your preset browser, okay? And there they all are. Now, since we had our items selected when we right-clicked on it, any deformer that we double-click on here is going to be automatically wired in and set to influence that mesh item, which is what we want, okay? So let's do this. Let's just play around with this for a little bit. Let's play with the, which one are we going to do here? Let's do this. We'll start off with the fun one. You guys are going to like this, okay? And then we'll advance on to some stuff that's a little bit more complex. Let's do the Vortex Effector. So if you double-click on Vortex, some new things are going to show up inside of your scene. I know, it is that cool, isn't it? Yeah. Okay, so there's your deformer. Okay? Now, before we go any further, and before we start messing with all these properties, let's look at what the computer has done for us automatically. Of course, it's added a new item in our item list. This is, yes ma'am, question?
Does it matter what size it is? Because mine's really tiny.
So if it's a different size than mine, don't worry about it, because we can change it, okay? It's all kind of dependent on how you created your cylinder initially. Patricia, did you have a question? You could, yeah. For right now, let's just look at it, and then we can go in and make adjustments to it, as we continue to move through it. Okay. So, believe it or not, I'm actually going to return to the schematic, because it's really important that we understand what's happening underneath the hood here, because it's not magic, okay? There is a series of rules and structures that will allow for this deformation to happen, and we can see that quite easily if we open up our schematic workflow. Okay, now, does anyone remember how I get something from my item list into my schematic? Drag and drop. Got it. I'm going to drag it down in here, and you can begin to see how all these nodes are working with each other. Okay? All right. Pop quiz. What does that little yellow diamond mean? Excuse me. If you look very carefully in mine, in the geometry channel of my Vortex deformer, I got a little yellow diamond, okay? That means there's a connected node to that little yellow diamond, okay? Okay, so...
How do you get the secondary node?
Oh, yeah, for whatever reason, yours isn't showing everything, but just click on the little yellow diamond. Double-click on it, I'm sorry. There we go. Yeah, and you can also double-click on your geometry to expose the input, okay? So if we look real carefully at what's going on here, there's actually two inputs to the deformer itself, okay? So new color, new icon, okay? Green. Green means deformer, okay? Green means this is something that's going to influence my mesh, okay? The inputs for this is the cylinder, okay? Because we need to tell the deformer which, chunk of geometry is going to get influenced by this general influence, okay, or by this deformer influence, excuse me. And then this effector is going to tell it how to influence, okay? So this is the what, this is the how, okay? This is kind of like the rules of how the deformation is going to happen. Yes, sir? So left click and drag your Vortex Effector down into your schematic. Yeah, from your item list. Yep. Drag it down here. There you go. Now double click on the yellow. Yes, sir.
Mine ain't like that.
Okay, double click on the yellow dots. See the yellow diamonds on the node? Over here? Yeah, double click on those. There you go. All right. Okie dokie day. So these deformers are accepting a whole bunch of different things. Basically all the little verts, okay? All the verts on the input geometry, okay, are being stored in this container, okay? 'Cause that's how I kind of think about it. These are actually kind of like little data containers, okay? There are actually empty containers that we can create more on that. You know, if there was a dedicated rigging class, we can actually talk about weight containers. They're pretty neat, okay? But these little containers accept a whole bunch of vertex information, and then we tell the container what to do with all that vertex information within an effector. So the effectors are physically the items inside of our deformation system that are going to be responsible for changing our mesh, okay? Let's go check it out real fast. I'm going to make this a little bit smaller. Zoom out. I want to select my effector, and you can either do it inside the viewport, or you can do it in the item list. 6 to 1, half a dozen to another, same thing. Okay. And with your effector selected, check it out. The properties panel is going to allow you to do a number of really cool things to your little cylinder. There we go. I'm going to give it a little bit of twist. You can start to see what's happening to my mesh. Okay? You can see it's starting to spin around a central place. Okay? Really great way to make ropes, by the way. If you want to model like the thread on something or a spiral, creating that pattern otherwise would be a challenge using our traditional modeling tools. But with deformers, we can just twist it real fast. Okay? Now with this particular deformer, we can make some changes to its location. Let's see, and the deformation will change. Now, with the vertex deformer, we're probably not going to see too much of a change in the result just by moving it up and down, moving it left and right. Yeah, that's kind of cool, because now we can have it spin like a tornado around the center point of the effector. Okay? So to answer Patricia's questions earlier, it does matter where the effector is in relationship to the model. Okay? Now, if we need to make a change to it, check it out. Notice what's going on here. Okay? Everything is kind of tornadoing around the center of my effector. And I achieved this just by moving the effector away from the center point. That's awesome, by the way. Good times. It's kind of flattening out ever so slightly. Yeah. There's a couple things that we can do to make sure that this doesn't happen. Okay? Or if we need to make a change to the location of our mesh. Okay? So here's what I'm going to do. If your object was placed away from the location of your effector, here's how we change it. Okay? It's actually really, really easy, and this is something that we're going to be seeing a number of times over the course of the next couple weeks. It's called setup mode. Okay? Setup mode, and I can understand the confusion. If the developers of the Foundry are listening, this is a great opportunity to fix the confusion, right? Because we have the setup layout, which is where we're going to find all of our rigging tools. Then we actually have setup tools, okay? And now we have a setup mode, okay? The setup mode is basically going to turn off all of our deformations and return the verts back to their original location inside of the mesh item. What this allows us to do, see how everything goes back? What that allows us to do is make changes to the components of our rig easily. Okay, so I'm going to move this, and there are ways of making this very accurate, but I'm just going to use the simple way. Okay, so I've just put my cylinder back in the exact same location as my deformer. If I return to the setup command, or if I turn setup mode off, you can see that that deformation is now active, and it's updating the mesh based off of the change that we made previously. Okay, so setup mode is really an opportunity for us to kind of get it back to its original state before it's deformed. Okay, really, really important for character rigging, right? Because if you think about it, we're going to set the rig up for our character in the T-pose. We'll see that here momentarily, okay? And then maybe in the process of animating, we pose our character like this, and we discover that the rig just isn't allowing us to get the pose that we want, right? How do we make a fundamental change to the original rig when it's all deformed like that? Setup mode allows us to do that. Click one button, the mesh will go back to its original bind pose, as they say. We can make changes to the rig, and then turn off setup mode, bloop, it will go back, right? It's a pretty neat system. You're going to see setup mode often over the next couple weeks, okay? It allows us to influence our mesh with kind of the rig almost turned off, if you will, if that's a better way of looking at it, okay? Now, deformers are pretty neat. I use deformers all the time in my animation process. The Vortex one is, I can't tell you how many times I've used the Vortex Effector. It's pretty neat. If you continue to explore the properties of the Vortex Effector, you can see that you can do some pretty neat things. Spiral amount is a confusing one for a lot of folks, okay? If you look I think with the given setup, you're really not going to see the effects of spiral amount. So let me do something here. This is actually kind of fun. Yeah, okay, I got it. I'm going to go into setup mode real fast. Basically turn off my deformer. I'm going to make my model much, much bigger. And here, let's do this just to make life easy. I'm going to return everything back to the origin of the scene. There we go. And here's a great little trick. Oops. Copy, paste. Let's try that again. There we go. Something like that. And now, let's do a small, simple radial array around the origin of our scene. There we go. And maybe you can start to see where I'm going with this. Okay. Awesome. Now, let's see. I'm making Twizzlers, yeah, kinda. Actually, because I added more geometry, the new points are included in the weight container itself. So let's do this. I'm gonna get rid of everything. There we go. And then basically redo the mesh, or redo the rig, because then you'll start to see the power of some of these other channels. So again, right-click, add mesh operation, and I'll double-click on Vortex. And this, in every sense, is kind of a fast, easy way to do a rope. Done. Hit the tab key, finito, as they say. That's a good, now that is a Twizzler, right? That's a great Twizzler, okay? With some additional modeling steps involved, you can get a pretty decent looking little rope out of that. However, watch what happens when I start doing the spiral amount, because the twist and the spiral are different things when it comes to this deformer, okay? And I want you to notice the shape of each one of the little strands coming off the top of my little ropey Twizzler thing here. Now, as I increase the spiral amount, we're both spiraling the entire object and twisting it at the same time. You can kind of see what we're getting, which is a very cool effect. Huh? It's you say pasta? Yeah, right? Try modeling that by hand, by the way. You just wouldn't be able to do it. Okay, yeah. One of the other things that makes deformers incredibly, and I mean incredibly powerful, is this idea that we can apply multiple deformers to one object, okay? Let me show you another really, really, really great deformer that I hope you use going forward in all capacities, whether it be modeling, animation, rigging, what have you. This is a neat, neat system, okay? Check it out. Once again, I'm going to return back to my item list and right-click on the item that I wish to deform. And this time, I'm going to choose, let's see, add mesh operation. Let's do the good old-fashioned, let's see, bend is so boring. Let's do Spline Effector. Okay. Now, the Spline Effector is, for some folks, a little confusing upon its initial setup, okay? What this effector is going to, or what this deformer is going to allow us to create is to be able to bend my rope along a curve, okay? And I get to control the points along my spline, and my rope will deform for me automatically, which is pretty cool. The thing that we have that everyone forgets to do the first time, and I'm included in this because this stumped me for a long, long time, okay, is that we have to define the number of edit points we want along the curve. That's pretty easy. But the part that got me was the length. Okay, so I want to put 3. I want that is initially pointed straight up and down along the y-axis. But how long do I want this to be? Okay, and this is the part that just got me. I just left it at 0, right? Thinking that the computer was going to put down 3 points for me automatically. Well, it did, but we have to space them out. And I don't know what this value is going to be. Let's see. I'm going to guess. Let's put it at 4 feet. Yeah, which was way too small. You can actually see the spline way down in here at these 3 dots. Okay. All right. So here's the big picture idea, and we'll fix this in a second, is that I now can start bending it that way. And I'm bending this along a curve. Okay. And I can select any of the points within the curve to continue to deform it. Okay. Now I'm going to go back in time a couple steps here for a moment. There we go. Does anyone remember from our previous conversation just 2 seconds ago how we can change the rig but not deform the mesh? How can we make a change to the rig and turn the deformation off? Whoever said it, you're absolutely right. Andy, do it. Hit me. Setup mode, okay? The setup mode is going to turn off the influence of the deformers. And it's an environment for us to make a change to the rig, okay? Because that's what I want to do. I want to make the width of my deformers, or excuse me, in this case, the height of my deformers a little bit bigger. So I want to return to the setup mode button, activate it. I like that the Foundry have given us a really good visual indication that we are in fact in setup mode. How does our viewport change to communicate to us we're in setup mode? Yeah, the yellow border, okay? And the background color of the viewport is slightly darker too, so it's a different shade. Now that I'm in setup mode, I can change components of my rig without deforming my mesh. Okay, so let's see if I can do it. Yep, so I'm going to take this first spline and move it way up here to the top. Grab the second one, the bottommost one, move it way down here to the bottom. There we go. And that's a little bit more what I want. So if I exit setup mode and start monkeying with things by moving these oh, I grabbed the vertex, sorry. So let's do it in the item list. Now, I can move this around. My little licorice is dancing, which is awesome. And you can see what's going on. Okay. If you continue to look at the details of our spline deformer, oops, there we go. We can do some really cool things with this deformer. Okay. Should we do one more? Okay, because there's some cool ones in here. If you look very carefully, yeah, see we're getting some pinching in this part of the mesh. Turn the visibility of my effectors off to make it a little bit easier to see what's going on. Yeah, see how it's kind of pinching a little bit in there? Can you guys see that? See how the mesh is kind of collapsing? We're getting some really weird pinching right there geometrically. Okay. Well, let's explore for a second the influence of our deformer stack. Okay. All right. Oops. And I'm going into the wrong place. I apologize. What we want to do, because there's an order of operation, an order of evaluation, if you will, that determines how the computer is going to deform this inside of our mesh, okay, or inside of our scene. And we get to that area to influence the order of operations of deformation under the Mesh Ops section, okay? And here it is. Here's the deformation stack down here at the bottom, okay? Now, in this section of our interface, we evaluate from the bottom up, okay? So what's the first deformer that's going to influence my cylinder? The vortex, you got it. And then the spline deformer. So in every sense, I'm twisting it, and then I'm bending it, okay? We can rearrange these, okay, to change the result and to change the evaluation process the computer is going to go through to deform my character. So what would happen, and I honestly don't know what this is going to look like, but let's see, this will be fun, okay? What's going to happen if I take my spline deformer over in the mesh operations stack and just left click and drag it below my vortex? Whoa. Something really unexpected and awesome at the same time. So if we talk through the logic of this, we're bending the entire cylinder first, and then we're taking that shape and we're spinning it, which is probably not what we want in this particular moment, but it kind of illustrates quite wonderfully how we can change the order of operation at any time to change the effect, okay? To get the right level of deformation or the correct kind of deformation that we're after. It's a pretty neat little system, and I love that it's incredibly organic, and you just change it around a little bit. Bloop. Okay. Pretty neat, huh? Okay, questions on working with deformers? Yes, ma'am.
I'm having trouble with the spline deformer.
Okay, let's take a look-see at it. What you got?
So I have it all here, but I can't like actually see it as you saw it there.
Right, let's see. Okay. Would you do me a favor and just increase the brightness of your screen for a minute? There we go. Okay, now I can see. Awesome. All right, let's hit undo a couple stages here. I'm concerned that maybe the spline,
Until the spline is done.
yeah. Let's just see what you were doing. All right, well, let's do this, because what's important, I bet you, keep going. There we go. Okay, cool. So show me how you applied, yep. Okay. Okay, increase this to something other than 1.
Okay.
Put this to like 3. Yep. There they are, yep. That may have been our initial problem. And when you're in your mesh ops section, you're not going to see all your items.
Okay.
So if you go back to your item list, yeah, there are the actual deformer nodes there.
Okay.
These locators represent the bottom, middle, and top.
Right.
So, okay, now we're working. If you go into setup mode, you can make a change to it real quickly to get what you're after. Okay. There are a lot of deformers inside of our deformer system. If you look at all of them, there's some really good ones in here. Some of them you've seen before, okay? Like the bend deformer. This acts in function very similar to the bend tool in our traditional mesh operations. However, we can change it, okay? And this is what makes working with deformers really, 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 really powerful, okay? It's not just a kind of a repeat of a tool. We can continue to influence and modulate that tool on what's called a vertex map, okay? An influence map, okay? And let me show you what that looks like. And I think probably the best way to kind of take a look at this is, let's see. Yeah, I'm going to get rid of everything. I want to just remove all of my influences. So I'm no longer deforming it, and I'll get rid of all this jazz too. Without those general influences, the deformers in the system. There we go. We're kind of back to it. All right. So I'm going to look at my scene here real fast and turn on the visibility of my grid. And because I'm a super nerd, I'm just going to center this along the y-axis, and I'm going to get very, very close. Center selected along the y. Okay. Now Pat can be a happy camper. That's just going to make the next portion of this example a little bit easier to see. Because I'm going to take my little rope here, and I want to bend it over first, okay? Just in kind of a linear fashion. But we're going to influence it with a vertex map in a moment as well, okay? Let's apply the bend deformer initially, and then we can control it with that vertex map, okay? So once again, let me just go into item mode. Right-click on my object, add mesh operation, do the bend. Now right now, it's kind of hard to see because it's chilling down there at the center of my mesh. You guys see the little dotted line that terminates in a little cube? That's the bend effector itself, okay? If we were to go over into our bend effector properties, the angle value here will allow us to change the bend. Okay? Now we're only bending kind of the first row, and it breaks pretty quickly. But you can see what we're getting here. Okay? Let's go into the setup mode for a second. I always make these changes in setup. Let's increase the length quite significantly. So it roughly matches the length of my little ropey Twizzler thing here. And then if we change the angle, yeah, now we're bending the way we want to bend. Okay? That's pretty neat. Okay? However, let's continue to go in and modulate the influence of this particular effector with a vertex map. Okay? The easiest way for me to explain what a vertex map is, or a weight map, and that's really what they're called. They're called weight maps. They define an influence of a tool. Okay? They're pretty powerful. They kind of at the root level of all rigging systems, okay? And it doesn't matter if you're rigging in Maya or in Modo or in Cinema 4D, we work with vertex maps, okay, weight maps to deform our characters. So this is going to be a thing you see everywhere, okay? This concept is pretty standardized within our industry. I really wish they would come up with a better one because it's kind of, you know, kind of feels like we're going in a time warp all the way back to 1985, but it is what it is, right? Let's look at how we can apply them, or how we can create them, change their weights and their values, and look at how their influence is going to create the result for us. Okay? So just to kind of make it easy on me and my brain, I'm going to return my bend effector angle value back to 0. Okay, there we go. Dun, 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 dun. And on the actual cylinder mesh item itself, okay, so weight maps are always, always, always applied to a mesh item. Because what we're going to be doing in here is that we're going to be going in and assigning a value, an influence percentage on a vertex. Okay? So some of this is going to be on a per vertex level. You'll see that here in a second. But we're always going to be assigning these weight values to an existing vert. Okay? An important idea to remember. These weight maps are going to go on verts, or they're going to influence the deformation of a vertice. Let's do it real fast. They're really easy to create. Okay? I got my cylinder mesh item selected, and then down here in my lists tab, of course, if you've taken other classes with me, we've been hanging out in the UV map world for a long, long time. Well, now it's time for us to start looking at weight maps. Okay? Now, there's almost always going to be 2 default weight maps that come with every mesh item inside of Modo. That's fine. We want these. Okay? We have a subdivision weight map and a B-spline weight map. You can delete these if you'd like, but your mesh is not going to subdivide correctly. Okay? So keep them there. They don't actually hurt anything. We're going to create a new one. Okay? Let's give it a good name. What should we name this? I don't know. Bender. Okay? We want the vertex map to be a weight map. You can see there's a lot of stuff in here. Leave it a weight map. Okay? Some of this stuff we'll talk about going forward in the future, towards the end of class. Some of these maps, I don't even know what they do, in all honesty. There's just a lot of stuff in here. In every sense, we're kind of exploring the back end of the Modo database, so we're just going to use weight maps. Okay? And the initial value is set to 1. Now, this is kind of the hard part that takes a lot of folks some time to transition into. Okay? We are dealing with influence, okay? Percentages of influence. Inside the computer development world, we work inside of a float number system, okay, that starts at 0.0 and terminates at 1.0, okay? What this translates into percentages is this equals, as one might imagine, 0%. What's this one? 100%, okay? So if I wanted to produce a bend of 50%, what would be the float value that I need to kind of zero in on? 0.5. Yeah, you got it. Okay, so we're working within a 0 to 1 scale, which translates over into a percentage scale. Okay. A lot, and I mean a lot, of the motor rigging system it works with inside this 0 to 1 scale. Okay? So we'll see that in a number of other places as well. Okay, so we're going to basically tell the initial value of all of these verts to be 100%. So they're going to receive 100% of our little bend, whoop, that we had before. Okay? Let's just hit OK. And I must not have confirmed. Here, let's change the name of that because I don't want it to be weight. Rename. Bender. Okay, there we go. That makes me happy. Now, if you're freaking out and you're like, why did my thing go red? Okay, that's because we're currently viewing our weight map. Okay, the way Modo communicates these values is that 100% or a vert that's been assigned an influence of 1.0 or 100% goes that color red. Okay. A vert that gets assigned a color a value of 0 or 0% goes this green, and I'm going to direct you toward Patricia's screen because you actually kind of see that green on her screen. You'll see it on my screen here in a second too, so for those on this side that can't see it, you'll see it again, okay? But green is off, if you think about it. Red is on, okay? Okay, if you don't want to see these, okay, you can actually turn the visibility of your weight maps off. And this is a good thing to do, especially when we're rigging. It's under the Active Meshes section of your viewport properties. And what we're looking to enable or disable is show weight maps. Okay? I usually turn it off because I can always go back in and look at my weight maps through changing my viewport shading style. Of course, we go to this button right here to change it from like wireframe or solid to shader scene through a different series of rules. If you've ever wondered what Vertex Map is, well, get used to seeing this because now we're in this world, right? Vertex Map, that shading style is going to look at the weight map that we currently have selected over in our Lists tab and show the vertex weight of every single vert that's connected to that map. Okay? So we'll be jumping in and out of the shading property or the shading style often. Let's return to default and continue our work. Okay? So how do we use this? How do we use this weight map? Okay? If we go over into our the actual container itself, the deformer, I clicked on the effector. It's in the actual deformer itself, the green guy. Check out its properties, okay? Right now, the type is set to entire mesh, but we have some options in here. We can tell it what specifically to use as the driver, if you will, of this entire deformation. And what do you think I'm going to choose? Yeah, weight map. And then I'll get to pick specifically which weight map I want to apply. Let's do weight map. I'm going to use Bender. Okay, that's the one that I created a second ago. Okay, and now it's using the weight of each, or the influence that's established on the weight map to deform my mesh. Now, it's not going to be, let's see what we get. If we were to bend the angle again, you're probably saying, Pat, that is exactly the same that we had before. And I would say, you're absolutely right, okay? What's cool about weight maps, as one might imagine, if we can initially set something's value to 100%, can I change the weight of other verts inside that same map? Yeah, absolutely. What if I only wanted to have the top portion bend? Or what if I only wanted to have the middle portion bend? Earlier we saw that vortex deformer. What if I wanted just the middle portion to spin, but the tops and the bottom to stay where they were, right? To stay in their original shape. That's where these weight maps really come in, because I can change and feather, if you will, the influence of a deformer across the entire geometry. Let me show you how it works. It's actually really, really kind of neat. We're going to keep it pretty simple. I'm just going to go back to undo here real fast, okay? And let's do this. Let's go back into our Lists tab, okay? And I'm just triple checking to make sure that my Bender weight map is currently selected. And I'll change the draw style of my viewport to Vertex Maps. And everything goes bright red, okay? Let's do this. Let's spend some time adjusting the verts, okay? So I'm going to go into my polygonal selection mode. And this is going to be so strange. I want to middle mouse click a marquee selection box and select the bottom half of my cylinder. Okay? With those polygons selected, I now can go over to the weighting tools inside of my toolbar. Okay? You're going to like these. Okay? They're a tremendous amount of fun. Okay? We'll talk more about this in detail and in relationship to character rigging towards the end of class today. But let's do this. Let's do, and I have a problem with this, but this is, my problem. Let's do set value. I'm sorry, not set value. We want to do adjust weights. Okay. Now, if you look, it's impossible to see at the moment because there's so many of them. Really, what it's doing is that it is giving us the vertex weight. If I have just one thing, there we go. I have one polygon selected. It's telling me the vert weights associated with that polygon. So each of the 4 verts, that one, that one, that one, and that one, all have a value of 100%. Okay? The adjust weights command will allow us to go in and change that. Okay? Adjust the weight of a selected vert. And you can do this in vert mode, you can do it in polygons, edges, whatever. I'll do it in verts. Now, what's confusing for a lot of folks, and I'm in this kind of bubble as well, is that they've broken the command section away from the tool properties. Okay? So if you think back into the modeling layout, you had all your modeling tools on the right, and then there's that big divider line in the center that showed you all of your tool properties below. Okay? Here, because there's so many tools and so many tool properties, they've broken the tool properties section out into their own tab. Okay? So to physically drive a specific property, we've got to go over here. Okay. So these are the tool properties that we're going to be adjusting. What I want to go in and do is disable additive, which is basically going to transform my 100% influence over to whatever I put here, which is going to be 0. And you can see what it's done over there. Okay? If it's on additive, we're adding the value in that channel box to the existing vertex weight percentage, right? So if for example, if all of these verts down here at the bottom were set to 50% weight, and I had additive turned on, and I had the value be 10%, what would be the weight, the new weight value applied to those verts? 60. Yeah, 60. Okay. So I'm going to turn additive off, which is going to replace the values of my selected verts. Okay. Now let's drop the tool and drop the verts and take a look at what's happened here, because we get a really great visualization as to how the computer is influencing or will be influencing our mesh. Okay. Where it's red, the part will bend. Okay, because it's going to receive 100% influence of the bend effector. Okay. Where it's green, which in the moto world means 0, it's not going to bend. Let's check it out. Return my shading style back to default. And again, I'll return to my bend effector. Looks awesome, doesn't it? Like I said, visually it's not a good look, but it illustrates quite wonderfully the influence and the purpose of these weight maps. It allows us to modulate that influence. Okay? Going back to our earlier example of working with the vortex thing, let me show you what I'm talking about. Here, let's do this. I'm going to put that back to 0. Okay? And here, instead of deleting everything, I'm going to stack deformers on top of each other. Okay? I don't want for this next section, I'm going to go in and I'm going to create a second weight map. Okay? And I'm going to highlight that center band. Okay? I'm going to make it red. Okay? And then I'm going to assign that new weight map to the Vortex Deformer, right? Which is only going to spin that center section. Let me show you what this looks like. Okay? So, because we can have as many of these weight maps as we want. Let's add a new one. Call this one spinner. And I'm going to put the initial value to 0. Okay? Which, if we have done it correctly, should be green. And it is. Aha! Awesome. Okay, so let's add that Vortex Effector back into my cylinder. Let's see, it's going to be right there. Double click, okay. And then with the actual deformer selected, because this is just the effector, this is the tool handle, if you will, okay. I'm going to go in. We got to set the system on the actual deformer itself. There we go. Oh, it loaded it in because I have it selected, which is good, in my lists map. I didn't, however, change any of my vertex. Well, I didn't change the weight. As one might imagine here, if I was just to run the effector now, what's going to happen? Is it going to twist? No, not at all, because every single vert has a value of 0. So I'm twisting my cylinder or my effector right now. Nothing's happening. Okay? That's because this effector is being influenced by this deformer who's looking at that weight map exclusively. Okay? Let's change the contents of this weight map, of the spinner weight map, to get the result that I'm after. So I'll return to my viewport shading properties and change it back to Vertex Map. Okay? And I'm going to get really specific here. Let's do this. Let's just grab that center band. There we go. And then, again, I'm in my weighting section. I'll adjust the weight to 100% this time. There we go. Get that cool little red band in the center. Let's start playing with our deformers now. I can bend it. Now the bend, I want to make triple check. Yeah, so the bender, let's turn, okay. I'm actually not going to use the bender weight map because that one's kind of breaking it. Let's just do none, okay? Or, we want to use entire mesh to completely ignore the vertex maps. So now the bend is going to do exactly what it did before. Woo! There it goes. Awesome sauce. It's working. Okay. Lovely. Okay. However, the vortex, it's going to probably be at a weird angle considering that I've bent it first, is only going to spin, spin that way, but it's only spinning the ones that have a value of 100%. Here, does anyone know how I can solve this problem pretty quickly?
Set up and change it, right?
Don't even have to do that. Flip the order. Yeah, flip the order of the deformers, right? Because really what I want to do, if I just want to have the polygons in the center spin, I want them to be spun first and then bent, right? So if I change, oops, got to go into mesh ops, excuse me. If I change the deformation order here, I want it to spin first, so I'll put that one at the bottom and then bend. Okay? Go back to my vortex. There we go. Cool, huh? That would be extraordinarily difficult to model, okay? It doesn't look good, clearly. I don't have enough geometry in there to get a nice kind of smooth feathered deformation, but we can adjust that, and we'll talk about that here in a minute. So deformers are kind of they're in every sense the underlying foundation for our entire character rigging process. Okay, they're pretty neat. They're pretty neat. Okay, questions about this? I want to show you something. This is kind of a bonus, something for you guys to explore in your free time. Okay, let me do this. I'm going to get rid of all of my. I'm going to get rid of all of my deformers and their associated effectors. Basically clear out my entire scene, get my cylinder back to where it is now. And before I go any further, I'm just going to rotate my polygons like that, 90 degrees. And I'm also going to center them at the origin. Okay. I want to show you one other thing. This is going to be, Pat, are you kidding me type moment. Okay. But it's well worth it, as they say. Let's see. Am I going to get what I'm after? Yeah, I'll make it. I'm going to make these a little bit longer. I won't get the quality of deformation that I'm after, but it'll still be fun nonetheless. Okay. So here's what I'm going to do. I'm going to add a couple locators. Okay. Two locators. Now I have got to remember. I may have the selection order wrong on this. Because I always forget what the selection order is. do I select the, I think I select the locators first, and then I select the mesh. And I'm going to apply, do I do it through here? Do I got to do it? It's called the slack effector. Let's see, did it work? No, it didn't work. I gotta remember, maybe I have the selection order wrong. Here, I have an idea. Let's throw this into my schematic. Oh, that's right. I forgot. Okay. That's right. It creates a group. There it is. Okay. So I went to the Groups tab, and I got to populate. I got to put both of my locators in that group. Okay. And then with both of those locators, you can actually drag them in there, but I always just right-click and do Y is add items. There it is. Aha! Oops. I got a vertex map in there. That's anticlimactic, isn't it? Let's just clear all that out. Actually, let's just delete them. So it worked for a second. Let me just return to my, yep, there we go. This is one of those things that it's kind of, working in Modo has its advantages, okay? Has anyone done wires before? Or like cabling? Yeah? Okay. You know, positioning cabling is kind of the most laborious thing on the face of the planet. Well, you can do it with a deformer. Right? Slack effector is pretty great. And since the input item are locators, you could parent those locators to a moving object, and then all your cables will move the way they're supposed to. You don't have to animate the cable, right? Yeah, someone showed that to me, about a year ago, and I went, are you kidding me? Yeah.
Can you do that with just a curve? And then
This one's kind of using some fancy math to figure out how to make it droop and actually stretch it out as well.
so does it actually require polygons?
Well, let me make sure I'm understanding your question right. We can't do this effect with like a spline, because that middle point is going to determine the arc. And here, that middle point is being calculated for us mathematically. They answer your question?
Yeah.
Yeah.
I was just wondering if you do that and then render a curve, using this.
Yeah, I believe so. Yeah, because curves can be, well, can you apply a vertex map? I'm not using a vertex map in this one. Give it a try. I've never actually tried it with a curve, but maybe. Yeah. I know that curves are dynamic items these days, so they are a first-party citizen within the rigging system. I've never actually tried it with a curve, but you can give it a try, see what you get. Pretty cool, huh? Yeah, the motor rigging system is pretty neat, pretty neatio. It extends past just doing characters and just making things move. I can't tell you how many times I've used that vortex and that bend in the modeling process, because what it gives you is it's almost kind of like a non-destructive editing process, right? Yeah, because once you like drop the tool, for example, like the bend tool, going back and changing that bend is kind of damn near impossible, right? With this system, I can bend it at any time and always get the change that I'm after. Okay, let's take a break. I think now's probably a good time to take a little break, okay? Let's see, be back at 3:25, please. know who you're talking about then. If this is the Diary of a Sad Cat, I know exactly. That's oh, I've forgotten his name. It's a crazy name. Yeah. I like the Sad Cat Diary ones are good. Day 84. My human captors are refusing to feed me. I will jump on their face at 3 a.m. to remind them I'm hungry. All that jazz. Anyways, okay. So let's kind of put a lot of what we have talked about in action a little bit. This idea of deformers is important. And I want you to take this with you, okay? Because you can and should be using deformers all the time in your modeling, okay? It is an invaluable part of my tool set. And naturally, if we want to make things move, we have to start adding some new elements in there, okay? So for a character, the application and the creation of deformers is a little bit more in depth, okay? But at the foundation of this, we have the exact same sequence. We're going to create a whole series of effectors, okay? And then we're going to create some deformers that look at the properties of those effectors to determine how the character is going to bend, okay? Now, this is a standard model that you'll see out there in the character world. Does anyone know what this pose is called?
T-pose.
This is the T-pose. This is the classic T-pose. Now, why do you think character modelers model something in the T-pose? It's easy, yes. And our character is symmetrically modeled, positioned right there at the origin of the scene. The appendages are at their extreme, right? It's easy to model like this. If you're modeling like a football player, this would be tough, right? This is easy, and then we'll bend and deform them into the pose that we're after, right? I did a Medusa head once, okay, with all the snakes in her hair, right? How did I model the snakes? Blink, you got it. They're all pointing straight out, right? And then I rigged them, and I bent them and coiled them into position, okay? It was pretty cool. It worked really, really, really well, okay? You're going to see this across the entire board, okay? This is kind of an industry standard pose, so this isn't just like Pat's crazy way of doing it, okay? Everyone models at the T-pose, okay? Our job to get this character to bend and deform is to go in and place a whole series of effectors first. These are the skeleton bones, okay? And it's pretty easy to do this, okay? I'm not going to do it for the entire body because that's your job. That's your homework this week. I'm not going to give you all the answers, but it's going to follow the exact same process, okay? So I think maybe what we'll start with here is looking at the spine and then one of the arms, and then I'll let you guys do the rest on your own, okay? Yeah, go ahead.
About the last one that we did, the deformer, Slack.
Slack, yeah.
Does that interact with a plane? Like if you have like a flat surface and you drop it over the flat surface, will it like will it go through it?
I'm gonna probably guess with great certainty that it will go through it, because there's nothing in the system at the moment that's getting the deformer and that plane talking to each other. There are ways to do that, and after the next module from the character rigging module is going to be dynamics, okay? And if we have that plane set as a static rigid body, and if we have our rope, our slack deformer, tagged as a kinematic rigid body, then they'll start influencing or being influenced to each other, because the physics engine will start sending these forces and this collision information between all the participants in the system. So I guess the answer to your question is no, but we can. And we'll get to that a little bit later on in the course, okay? Let's jump back over to our green dude. Okay. All right. So first things first, let's go in and start placing just a few joints, okay? Previously, we were creating effectors. Joints are basically like the exact same thing. They're the object that we're physically going to be manipulating in 3D space that will tell the deformer how to bend and move our character around, okay? I think it's really important for me as I go through the placement of all of these joints to understand that I'm placing joints, okay? Locations inside of my character that are going to rotate and bend around, okay? I'm so happy. Patty must be looking at my notes here, because if you jump back over into Canvas, I've given you guys a really great little map, okay, of where all these joints can go. This is about as close to an industry standard application of these joints as we can make them, And I think this is where character rigging gets tough because it's all contextual, right? Certain characters are going to require more. Certain characters are going to require less. This is kind of our standard like bipedal setup, okay? Each studio is going to do it a little bit differently, but this is, at the very least gets us in the door, okay? It's amazing what people will put joints on, right? I've seen joints in hair, I've seen joints in ears to make them wiggle. It's amazing. The root, so we're going to talk about that here in a minute, yeah. And so we're going to do the spine and then one of the arms, and that will hopefully give you a good understanding of how to do the rest, okay? Let's jump back over into Modo real fast. Okay. And I'm going to look at my scene from the front, because it's just going to be a whole lot easier to see what's going on. Okay, so we can find our joint tool in this setup tab. It's right up there at the top. It's called the skeleton tool. Okay, this is going to allow us to go in and place a whole series of joints on top of the mesh. Okay, I think it goes without saying that it's absolutely critical that our geometry be placed at the origin of the scene. Very important. Okay, that way we're getting the correct placement of the joints in relationship to the mesh. We have a point of reference that we can align these joints to. It makes the process of getting everything kind of synced in pretty easy. So let's go into the skeleton tools. And specifically, I want to make sure that we go over to our tool properties. Okay. A couple things to double check before we start clicking down some joints. Make sure your tool properties look very, very similar to this. Okay. At the moment, we're going to leave symmetry off. Okay. I'm going to leave it off. Okay. I don't know who's been messing around with the rigging tools on these machines before you guys walked in. So just make sure that symmetry's off. Align is in Z direction, x-axis, and the preserve alignment's on. Okay. All right. Okay, so let's talk for a second about what we're going to initially create. Okay. We're going to create a whole series of bones, if you will. Okay. But there always needs to be a master joint. Okay. The king of the castle. You know, the controller of the entire rig. We've seen this a couple times before, okay, on our earlier projects, that root controller, that world controller. We need to have a member of our character rig that is the driver of everything. It's often referred to as the root, okay, much like we were working with before, okay. And I'm going to close the blinds here just so everyone can see the board. I'm so very happy. My request for a moving whiteboard was approved, so we're going to get a big whiteboard they can roll around and draw things on, make it easier for you guys to see, because this is tough, right? You know, much like we did before, we're going to be creating a hierarchy, okay? So here's the root joint, okay? And it's going to have a whole series of children. You know, this could be, you know, the spine, another spine. I'm not going to go through all of them because you'll see that in the handout that I gave you. But then it's going to start to branch, right? The hierarchy is going to change. Okay. So I'm going to skip forward. This is neck. And then what's connected to the neck? Well, the head is connected to the neck. Okay. Actually, if you look at the document, it says like neck base and neck's top. But there's a head in here. But there's also going to be some children, right? Arm. Okay. The actual skeleton itself is going to be a very, very complex hierarchy. Okay. Not everything is going to be at the same level. Okay. We're going to branch. Okay. Like the neck, or I forget what it's called in the handout, and we'll look at it here in a second, is going to branch off the arms. And we do this so we can control each arm individually. We want to have something in our hierarchy that's going to control the entire skeleton, right? You move the root, everything moves, right? However, often, I want to be able to move my arm of my character, but not move my spine. So having it in its own separate hierarchy, a child of one bone, you know, for example, allows us to localize these controls and edits on different parts of our rig. Okay, let's start laying down some joints. So we're going to be creating a pretty intense hierarchy. Let's start off with the creation of the root bone, okay? Now the root, this is kind of a practice thing, but for most people, the root kind of goes in an area where we don't often control, and that's kind of like the tailbone area of your body, okay? So I'm gonna put it kind of down in here, okay? Now from the front, and I recognize it's kind of hard to see. Let's see, is that better? Yeah, that's a little bit better. It's kind of hard to see, but that's a joint, a circle, okay? Now, I'm a big believer that as we create these, we should put them into position. So I'm just going to kind of put it in the back, out of the way a little bit, okay? This isn't something that we're really going to be rotating, but we do need to have a parent of our entire system, okay? And so now, let's go in and start placing some, I'm looking at the anatomy here of my character. Yeah, the hips are kind of right around in here. Let's place another one for our hips, okay? And this is what the computer is going to draw for us. The big circles are the joints, okay? And then what's drawn in between is, I guess, what you would probably refer to as a bone, okay? I would encourage you to think of this process as the creation of joints, and the computer is going to create the bones for us. Because the joints are really what moves, right? Right? Our bones just kind of come along for the ride. I mean, if you're rotating your elbow, the bone between your elbow and your wrist, it doesn't really do anything. It's just kind of a static, kind of board, right? I rotate my elbow, and of course that board comes along for the ride. Right? Make sense? So the bones we really don't care too much about. All right, so that could be my hips. And I almost always, at a practice, put a couple in here to control the spine. Okay. Go ahead. Question, Demetrius? How do I what? Duplicate them? So, I have not dropped the tool yet. So with the tool still on and active, I can add as many joints as I want, and they'll always be connected to each other. Okay? Now, it's a good question. Let's pretend that you went there and you dropped the tool on accident. Yeah, it's like, oh crap, now what do? I clicked off it, my bad, right? Is there a way that I can go in and continue adding joints to an existing skeletal structure? Yes, you can, okay? Here's what you gotta do though. Of course, we're gonna be in item mode. I'll select the root bone, okay? If you return to your skeleton tool in your toolbar, Modo will understand pretty quickly what you clicked on, okay, or what's been selected. The joint item inside of Modo is a special item. It's not like kind of a standard locator that we've been working with in previous assignments. It knows on the back end of the database that what you've just created is a joint, okay? So if you have one clicked on and then you refire the skeleton tool, you can continue adding joints into your system. Now, I want to add a joint from here, so I want to make sure that that one's selected and then continue clicking and adding a few joints into the system itself.
Okay, so you click on the one that you want to continue and then just click on
You got it. Yeah, you got it. The gold one is kind of the active joint, and all new joints are going to be added after the active joint in the hierarchy. Now, I can see on your screen, Demetrius, that you've shaded your viewport using the Vertex Map. What if we changed your shading style? Yeah, put it back over here to default. Okay. All right. So, turn off your tool. Turn it off. You got it. Now, I want you to click on one of your skeleton joints. Just click on it. Now, return to your skeleton tool. Yeah. See how you got a blue dot there in the center? Yeah, click on it. Now, that's the active joint, right?
Yes.
If you were to click up here, no, don't drag. Just click.
Right? Click up here.
Yep. See? There you go. All right, so let's get back to our example here. Now, I simply just double-clicked on the root bone in my skeleton. to select all the components of that hierarchy. And let's look at what the computer's done so far, because this is kind of one of the challenges of creating an internal bone structure, is looking at the hierarchy that we're building from. Okay? It's a good idea to name as you go, okay? Because here is all the skeleton joints that we've created so far. And the default naming convention doesn't help, doesn't it? It's just skeleton joint 1, 2, 3, 4, 5. What's the context? What's the role of each one of these joints inside of the model itself? So here's what I would suggest that you do. Name as you go. That way you're not confused as to what in the world it is that you're making, okay? So I'm going to call this root. Here are the hips. And I think this is just spine underscore 01, 02, and then I have a third spine in here, 03. Okay.
For the hand, do we have to do every individual finger?
Yes, for the hand you will do every single finger. Okay. Yeah, it's not so bad, but every finger gets done. Because it's the only way to close your hands, right? To make a ball, right? If you want to have the fist's ball, you got to have something in there that's going to tell it how to deform.
Yeah, it's fun to use symmetry for that.
Yes, yeah. We'll talk about that here in a minute. Yeah. Okay. So here's my little structure so far. You can see the hierarchy that I've created. Okay. Now I need to go. I'm going to continue placing a couple more for the bottom of the neck, the top of the neck, and the top of the head. Okay. Let's just do that real fast. So with my skeleton selected, I can return to the skeleton tool. I'm just going to make sure that that guy right there is the one that's selected. So let's see. There's the bottom of the neck, top of the neck, then top of the head. Okay. Now we're creating a hierarchical chain here, if you will. For every chain, we need to have a termination point within inside that chain. A lot of you guys are probably wondering, why, Pat, why in the world did you put a joint at the top of the head? Okay. Well, that joint at the top of the head represents a termination. We need to have something for the previous joint to rotate from and to. Okay. So if I want to be able to do, kind of this motion with our head, okay, that bottom of the neck or bottom of the head joint isn't going to rotate unless there's something on top of it, because we need to have a bone, right? Does that make sense? Okay. Now before, Mike, you had a question. I want to make sure it gets answered. Okay. I excel at solving problems.
I'm selecting the bone.
Okay.
I want to continue, so obviously the topmost one. I'm selecting
right.
item mode. I'm clicking skeleton.
Yep. Oh, okay. Here's your problem. Hit undo. Click on that little blue dot on the inside. Yeah. There you go.
Oh, okay.
Yep.
So when I click on skeleton, I got to select it.
Yeah, it's basically just going to recognize all the skeleton joints that are existing in the scene, but you still got to tell it where to start from. Actually, we'll see that here in action here in a second. Okay. One other thing, can't recommend this enough. Okay. As you place your joints, don't try to place all the joints at once, right? Because you're just going to confuse yourself as to the role and the correct position of these joints. So do it in little chunks. Okay. I've just done the spine. Before I move on to doing the arm, maybe I spend some time moving these joints to where they should naturally be in three-dimensional space. Okay. From this view, looking pretty good. Okay. From this view, I have some work in here that I need to do. Okay. Oops. Let's go into the item transform tool. Okay. And I can start clicking on the ones that I want to have somewhere right around in here. Now your hips need to be kind of where the hip socket is. Okay. Now for the spine, we want to place these joints where they would naturally appear in the anatomy, right? Is your spine in the center of your chest cavity? No, it's right along your back. Obviously, you can run your finger down your own spine. So our spinal joints need to be towards the back of the mesh. That way we get the proper deformation of our character in our animation. All right, so just going to use these to define the curvature. Now we get up here. Now I'm looking at the actual, so this bone in here in every sense, it's a little low. There we go. Now when you're adjusting your spine joints, okay, or any of the joints, you can go in and make adjustments to one and not have them influence the rest, okay? Let me show you the problem that we're currently facing. And I'll just turn off my green dude so it's a little bit easier for you guys to see. I got a joint down here that represents the spine. Let's pretend that I want to just edit that joint's location in three-dimensional space. Right now, this is what we're going to get. If I was to move it, it's going to move everything that follows it inside the hierarchy, all of its children. What if I just want to influence that one joint and not have to worry about the rest? Okay? In order to do that, we need to turn on what's called compensation. Okay? With compensation, oops, that was the wrong one. It's this one, child compensate. I'm in the item transform tool, and it knows what we've selected. So if you do child compensate, then yeah. Then we just rotate that one joint, or we can move just that one joint. Okay? So I'm in the item transform tool. Yeah, the Y key, and it's just this command right here, child compensate.
Is that the properties?
The tool properties, yeah. Yep. Oh, tool properties over here.
Mm-hmm.
Yep.
Oh, okay.
Yep.
That's what I'm
just trying to find where that is.
The tool properties or
Well,
what?
I found the tool properties.
Great. Oh, okay, yeah. So I'm in a little bit different position. If you look, you're still adding the joints, which is good. Do me a favor, just drop your tool real fast. Hit the space bar. There you go. Okay, now grab like that bottom, like that joint right there. There you go. Hit the Y key to fire off item transform. Okay, now if you were to move it, watch what happens. They all move, right? Hit undo for a second and turn on child compensate. Now if you move it, just that one moves. Cool, huh? Sure, if you'd like. Okay. So let me take a look-see here real fast. Turn on my green dude. Things are looking good. Very happy with the placement of this. I may have gone a little too crazy there. Basically what I'm trying to do with the placement of my joints is, excuse me, there we go. Just kind of replicate the curvature of the spine. Yeah, that'll do, as they say. Okay. However, now, question, yes, sir.
So when I turned it on the child compensate thing, one of the joints kind of slanted a little on top of the head.
Okay, fix it. Is that the one you want to fix? Yeah.
Okay.
All right. All right. So now let's take a look at the hierarchy that I've created. I've added a whole series of new effectors into my hierarchy. So it's a good time to kind of, do some housekeeping. Head top, head base. This is neck, oops. Base, and it renamed that one for me. How dare you? There we go. So spine 1 through 3, neck base, head top. Okay. So I need to go in and create a new hierarchy for my arm. Okay. Now this is where it gets kind of fun. Okay. There's actually a couple different ways that we can do this. Okay. If you think about the big picture idea here, we're just creating joints, but then we can always insert those joints into our hierarchy at any time, or we can remove and extract, entire appendages if we want from an existing hierarchy. If we wanted, and I'm going to double click on my entire skeleton here to click on it, we certainly could just return to our skeleton tool And then instead of having the topmost, this guy up here selected, I'm going to click on the joint that I want the branch to begin from, which is kind of right there. So I have one for the shoulder, one for the elbow, and one for the wrist. We'll move into position now. Something like that. I'm not going to do everything because that's your job. Okay? I'll drop the tool, and again, let's just take a look at a hierarchy because this is kind of the most important part when it comes to the skeleton. Okay? Here's the spine. If you just collapse and look at its branch, we have the skeleton has a child neck base, but then this spine 3 also has a new branch. This is the arm. Okay, so this is the so I'm going to do arm, right, shoulder. Okay. Arm, right, elbow. There we go.
What's the trick for getting it to start again from the skeleton?
Yeah, just I can even go back and I'll do it again over here if you like. So I just have the skeleton selected, and any joint inside of your hierarchy can be selected, and then just return to the skeleton tool. Okay.
Right.
Click on the joint that you want to branch from.
After clicking the skeleton tool?
You got it. Yep. Yeah, because remember, all joints are going to be created from whatever one is selected, whatever one's gold. Yes, ma'am.
Okay, so I had a problem with that. Like when I would try to click on the joint, it wouldn't work that way. So I went through the item list, and it ended up doing that.
So
like
you
it
just
reversed.
parented? Yeah.
Yeah.
Okay.
I mean,
That's the
does
other
that
way of doing it.
still work?
Still works.
Okay.
I mean, that's the.
It's visually different, but not in the
Yeah.
way.
So this is the problem that Catherine ran into. Okay. Just if you look very carefully at how the computer is drawing the relationship between the branches in my hierarchy. Okay. See how on mine it does this little single 1 pixel line. Okay. At times you're not going to see that. It's going to draw a bone, which is absolutely fine. I don't know why it does that. I really don't. I don't think there is the order of operation. Yeah, that doesn't surprise me.
Because I switched them around, and it changes which one.
Bloop, bloop. Yeah, the deformation is going to be the same.
Does it still use that path that's there as kind of a
It's
guide?
not even really. Well, if you think about it, it's a visualization of the relationships between the two joints themselves. It doesn't do anything. It doesn't like bend or mesh, in between those points. The circles are what bends. Everything in between a circle is just a visualization of the relationship between the circles. For example, and this is a really great kind of hierarchical visualization here. I can unparent my entire right arm from my skeleton. Okay? You see what happens? That visualization kind of goes away. Okay? I know some people that do this just kind of by their technique. They'll make individual hierarchies for all their appendages, and then they'll parent them and insert them into the hierarchy in the appropriate places. You can absolutely do that. Okay? Yeah, you can absolutely do that, right? If you think about it, we've been doing this, a number of times this semester already, right? You just drag it on top of skeleton spine 3, bloop, and see, look now. See how that visualization has changed? Yeah. So this is kind of arbitrary. Probably it's another reason why I kind of jump up and down about the circles. You place joints, the computer creates the bones for you. Okay. Haha, there it is. Awesome, looking good. All right, so what do we do with it next? Okay, now I'm not going to go through all of this because that's going to be your job. But the next part is to physically attach the bones to the character itself. This is called binding. This is where we physically create a whole series of deformers, okay? This stage, the joint stage, we're creating effectors right here. Okay? These are the widgets that we're going to use to control the deformers. Okay? So in order for us to physically glue the skeleton to the mesh, we have to bind these two pieces together. Okay? Now there's a couple steps in here, and this is one of the few parts of our sequence that we really have to honor and be very careful to make sure that we're going through the correct sequence and in order, because if we deviate, it's just not going to work. Okay? So here's the first step. We have to select the mesh. Okay, excuse me. We have to double click on the joints. Okay? If you double click on the root joint, everything is selected, right? Then you hold down your control key, grab your mesh. Okay? So joints first, then mesh. Okay? Remember the idea in Modo is this to that. We want to bind this to that. Okay? Select the joints, bind it to the mesh. Okay? The part that a lot of folks kind of skip on accident is that we now have to enter setup mode. Okay? Because we're creating a default state for our rig right now. Okay? This is often referred to as the bind pose. Okay? Every time we enter setup mode, our rig is going to go back to bloop, the T pose. Okay? So we initially create the deformers in the bind pose, in that T pose. Okay? And then with that in mind, we can go over to our deformer section. And if you have successfully gone through that entire sequence, the bind command is going to become ungrayed. Okay? Click on the bind button. You'll get a little popover that asks for basically an algorithm to be applied to the mesh itself. And this is where the character rigging tool sets across our entire industry diverge pretty quickly, because every software developer has their own algorithm. Okay? What these algorithms are going to do, each one of them is going to look at a joint, and then it's going to do some crazy math to figure out which vertices are around that joint. Okay? And based off of the math and the algorithm, a percentage of influence is going to be assigned to each joint, right? So if in the context of our arm, the joint that represent our elbow, it's going to send out a whole bunch of rays from it, if you will. And those rays are going to be are going to detect all the verts that are right around the elbow, and just those verts are going to be assigned to the influence of that joint. So when I rotate that joint, just those verts move. Okay? These bind types change the math and change the algorithm. There's some good ones in here. The one that will almost always work and give you pretty solid results is going to be smooth distance. Okay? One that's pretty magical, and I honestly don't remember if it's going to work well with this one, is heat. Okay? If you can't get heat to work, do smooth distance. That one will absolutely work. Let's just see if heat works. We'll hit OK. Now, you may have a rainbow body on your screen. Let's do show weight maps. Yeah, there we go. Okay. Now, just so everyone's on the same page, under my viewport properties, under the active meshes section, I had my show weight maps turned off. That was from our previous example of working with the deformers, right? With them on, I now can double click on the root and see a rainbow boy, okay? What we're seeing here are all the different vertex weight maps that were created for my character and their relative position and weight value on the mesh itself, okay? You can click on each one and see the influence of each joint inside the mesh itself. So where it's red, so that one did a really bad job. Okay, we can go back and fix this, okay? That one's pretty good. Select here, yeah, okay, cool. All right. The part that you love to hate, and everyone loves to hate this, is the adjustment of each one of these vertex weight maps, okay, to get the proper deformation. Let's give ourselves some confidence that we've done an actual, that it's worked, right, that we've done our job. If you exit setup mode and select a joint and then rotate it, Yay, it moves. Woohoo! Awesome sauce. That's what we're after. Grab like the back, rotate that down. Not so hot. That's because my child compensate's still on, so I was only rotating that one joint. There we go. Yeah. So it's worked, okay? We've been able to effectively glue the skeleton to the mesh, and the computer's gone in and created a whole series of vertex weight maps for us that's determining how each one of these verts are rotating around their associated joint, okay? Yeah, it is rather entertaining, isn't it, Mike? Go in and break your mesh.
Oh, absolutely. I'm in the Rafflecopter, man.
Yeah, so it's like, yeah, the computer's not going to stop the rotation of these guys. Okay? So our job now is to go in and to continue to refine and adjust the influence of these verts on the mesh. And if you look at mine specifically, check it out. All right. I have that spine joint selected, but look what the algorithm did. See how where it's all pink here? Okay? When I move this spine, all of this jazz is going to move too. Okay? Oops. Now, normally we wouldn't want to have that entire arm be red, okay? Because when I move this joint, I just want to have, the arm joints on this side should be moving or should be rotating. Let's see if I can find a really offensive one here. Okay, so when I rotate my root, which you'd really never do. Okay, here's a great example. So I rotate my hips, my feet are coming up off the ground. I don't want that, right? What should be the part of the body that moves when I rotate the hips? The hips, just that area. So you want to localize the influence of a joint to what logically makes sense, right? Only the verts around the hip should be red. Everything else needs to be green. This is called paint weighting, where we go in and turn off the influence or adjust the influence of a joint on the mesh itself, okay? And it's a process, okay? This is it's a process. Let's put it that way, okay? And you have to do it on every single joint, okay? You basically have to double check, because remember, the computer is using an algorithm, math, to figure out what weight to assign each of the verts, okay? It's going to get it wrong, okay? So it's our job as artists to go in and triple check, assign the correct values, okay? Luckily for us, there's a pretty organic way of doing this, okay? Let's go over to our commands section. And before we get started, I think it's really, really important to note that I have a joint currently selected, and I'm viewing the weight map that's assigned to that joint. On every single joint that's created, or every single joint in my mesh, a vertex map, a weight map was created for every single joint, okay? So if you have 80 joints in your mesh, you now have 80 different weight maps in your model, okay? Because each one of those is assigned to the respective joint, okay? So I want to edit just this joint's vertex map, its weight map, okay? So that's why I have it selected. You could, if you wanted to, go into, let me prove to you that I'm not going crazy here. Okay. So back to that lists tab that we were talking about earlier, okay? They're all weight maps, okay? I could, if I wanted to, select each individual one, and I'll see just the weight map for that one. Another great way of working. Saves you from not having to select on each individual joint. You can select in the list. This is why our naming conventions are so important, because you can see that the name of the joint was copied and pasted into the name of the weight map that's associated with that joint. If you just have, if all of your joints are named skeleton 1, skeleton 2, skeleton 3, skeleton 4, this is going to be a nightmare of an environment to work within. So you want to name stuff. All right. Let's go back. What was it? Was it this one? Which joint was it? It was that one. Okay, cool. So spine 01 for me, I need to make some adjustments on. Now, there are a couple different ways that we can go in and adjust all the weights associated with the vertex maps. The weighting section of our toolbar is going to allow us to do that. Now, there's a couple ways we can do it. For big areas, like this stuff down in here, I'm going to go into just my vertex selection mode, and I'm going to select a whole bunch of verts. Okay, we did this earlier. Now, my adjust weights section here will allow me to assign a weight. Now, right now, the weight is set to 100, and that's what we get, okay? Because I'm being silly. Let's just look what happens when I rotate that joint. Yep. Yeah. Because now, if you think about it, the verts that have 100% weight are receiving 100% of the rotation of that joint, right? Now, down here at the bottom, what do we want to have the weight of the bottom of my legs be? 0. We don't want those verts to receive any influence from the rotation of that joint. So let's make a change. And you can even do this while a value has been assigned to your model. This is one of the cool things about this system, is that I don't have to go back into setup mode. Okay, I can just return to my adjust weights, put it at 0, and they go back. That's cool. All right. However, I probably don't want these in here to move too much. Okay, so I'll do the same. Adjust weights. One cool thing about adjust weights is you can actually left-click and drag and interactively assign a weight value. So it makes it pretty fast. If you'd like, one of the other options that you have is to use a brush. Okay, so you don't have to use just yeah, Catherine, go ahead.
Something odd is happening with your guy here.
Let's check it out.
So I tried to do everything to 0% and
Okay, let's see what you got. Okay, do me a favor. Click off, turn off the tool real fast. Okay. Now, I think probably the problem is that you have another joint in this hierarchy that has influence down here.
okay.
Click on that one. Now that's good. Now click on the one above it. One above it. It's that one.
Okay.
Catherine just ran into something that's really, really important for us to remember. Okay. Let me put the rotation of this little guy back to where it was, 0. Okay. All right. So the problem that Catherine ran into just now was that she was rotating, I think, one of the lower spine ones like I was, right? And she cleared out the weight of value associated with all this other stuff down here, okay? And she did that, and then her foot started to move. And she went, what? I cleared it out, right? I put the value to those verts to 0, WTF, why is this still moving, right? Keep in mind that when you rotate one joint, you're actually rotating every joint that comes after it in that hierarchy. I don't remember specifically which one it was on Catherine's, but the weight, yeah. Let's just pretend it was this one up here, okay? This joint also had some sort of weight associated with these bottom polygons, okay? So when she rotated the one below it, this one also rotates, right? Rotating the hierarchy. What happens to one, what happens to the parent influences the child, okay? And so we are getting this really awesome transformation, okay? Let me illustrate this as the best I can. Okay, so now my dude's straight up. I go to this character. I'm actually going to add weight to these bottom verts. We'll adjust weights. We'll put it at 100. Okay. This is why I got to double check. That one's good. Okay. And if you think, whoop, okay, the feet are moving because the joint immediately above it in the chain is also rotating, and that joint has the influence on the foot. Okay. There we go. All right, I'm running out of time. I just want to show you this real thing real quick. You can also use brushes to go in and kind of artistically, assign these values. I don't know if it's a faster way, but it's just definitely a different way of going in and assigning these weight values. Okay. So let's do this. Let's just use the paint. Okay, I'll use a soft brush. Okay, the tool properties are what most important here, because this is the value that we're painting in. Okay, the normalized weights, we're going to talk a little bit more about this next week when we have some time. Okay, basically what this means is that each vert can only be influenced to a value of 100%. Now, 50% of that influence can come from one bone, 10% of that influence can come from another, and then 40% of that influence can come from a third, okay? But the total influence on a single vert is always going to be 100, okay? That's called normalization. It ensures that each vert works within that 0 to 1 scale, that it's not accidentally going to go above or below, okay? So having normalized weights on is a good idea, okay? So the right mouse button will allow you to go in and change the size of your brush, and then you can just paint on top of the mesh, okay? Just paint on top of the mesh, and you're adding weight in a value of 50. With the soft brush, it's actually feathering it, so where it's in the center there, it's probably at 100 or very close to it, but then it's going to feather its weight around the outside of the brush. Okay. I haven't actually tested this, but believe it or not, symmetry is now an option for us. I don't know if this is going to work. Let's find out. Haha, they actually have it working today, which is fantastic. I know the developers down at the Foundry have been working very hard to allow you to symmetrically go in and affect your paint weights. Yeah, it's nice, because then you don't have to really work on one side, and then the other side's taken care of for you. Okay? Yes?
I'm painting with a brush and nothing's happening.
You're painting with the brush and nothing's happening. Let's take a look at it. We're running out of time, so I don't want to keep you guys much longer. Okay.
And I'm here and I got my paintbrush on, but it's set to 0, but if I paint nothing happens.
Okay. Go back to your commands. Let's see what brush you're using.
Should be paint, right?
Yeah, it should be paint. Oh, no. So whatever that value is that's assigned, you're not adding anything to it. You're adding 0%.
Oh, so it should be...
Put it to like 10%.
Okay. Can I get rid of with the paint?
Yes, absolutely. So now you're reducing, or you're adding 10% weight, I think, to all those verts.
Maybe just try something that it will actually show up.
100%. Yeah, it's changing its color.
Okay,
Yep. Yeah. Now, if you wanted to remove it, I believe there's a hotkey that will do the opposite, but there's also set value and erase down there below.
Oh, erase,
Yep.
okay.
Liam, what you got?
Before we head out, I'd like a little advice on something. I'm adding bones to both arms.
Mm-hmm.
I originally had some here, but I deleted them because they didn't connect to here.
Okay.
I'm just trying to get them connected to the body.
Yes. Okay, great. So jump out of your rotate tool. I want you to double click on your skeleton. The whole thing. Okay. Oh, you've already bound it on.
But just a second.
Okay. So Liam just ran into, I think, an important little landmine that we all should be aware of. Okay. You only get one shot to glue your skeleton to your mesh. Okay. You have to have your skeleton complete before you bind. Okay. Because remember, we were taking a vert and we're assigning it to a joint. Okay. If there's no joint in that area, that vert is going to be assigned to the influence of something else, right? We can't reassign these verts kind of on the fly, okay? So big picture idea, you need to have your skeleton done before you bind, okay? Now, you can unbind, okay? You can fix this, okay? You can fix this. It's kind of a back to formula type moment, Okay. Now I have everything glued in there. They have moved it in this version of Modo. It's under groups now. Well, let's do this. There used to be a folder in here called Normalization. Thank you. That's where they moved it. Right there. That's your normalization folder. Now, you used to be able to go in and see every single vertex map in the normalization tab, and maybe they have changed it a little bit in this version. However, let's just delete the normalization folder, because that's basically what you do. Of course, you can't delete it. Let's go into setup mode. You still can't delete it. Yeah. Mine's not showing up. Yeah. I am in setup. Let's do this. Now I'm still in setup. There we go. Now what that does, the normalization folder is kind of that's the actual element that glues these vertex maps to the actual joints themselves. Let's just make sure that this is in fact turned off. Yep. So what you could do is delete that normalization folder, go into your lists tab, then I would also delete all of these weight maps as well. Get everything back down to just the skeleton and the geometry. Yes, sir?
So I need to have this, all the bones laid out in the parts of the body I'd like to move before.
Before you do the bind, yeah. Before you have to be done with your skeleton, okay? Now, as I mentioned, if you delete this folder, and it's nested underneath your mesh, if you delete that folder and all the corresponding weight maps themselves, you'll basically unbind your skeleton from the rig, or your skeleton from your mesh, excuse me, okay?
All your joints, it looked like they were set like properly. They had the XYZ axis on the transformers. Mine were kind of all over the place.
Yeah, and the floor is yours, Indigo. Oh, is there a way? I thought you said there is a way to change them. Yeah, you can rotate them. Yeah, absolutely. You can rotate these.
But without changing,
So yeah, to get them back
so
to
that
the
they're
default.
naturally at 0 when they've been rotated.
Right.
Because you can
Okay.
rotate them, but then they're 0
Yeah.
changes to be another
In setup mode.
instead of
In setup mode. If you go back into setup mode, then you can rotate them. And, if they're twisted, you can get them back in alignment. If you want to really replace their orientation, you can do that. Yeah.
and that'll be like their 0 point.
That'll be their 0 point. Yeah. This would be something that I would probably recommend that you do before you bind. Yeah.
Right.
Give your skeleton a good triple check. Make sure that everything is oriented the way you want it. Because it's, for me, when I bind it, it's kind of a point of no return.
Because
Right.
cow, but when I was making the skeleton, like certain ones would be off.
Yeah.
They wouldn't be like on the perfect.
Is there a way
up
that you
and down.
place them? Because it looks like on your model that everything was placed like
Really kind of
I've
accurately.
seen, yeah.
Good tip, I do these in orthographic views. So I remove any sort of perspective warping for the tools, okay? I look at my scene from the front, I lay down my joints, okay? I look at it from the side, then I move them. That kind of eliminates opportunities for twists to happen inside of your hierarchy. So,
Even still happens sometimes.
It-
I think my twist happened in an orthographic.
yeah, and I've had this happen to myself. It still happens. It still happens. I think the big takeaway is we have to be okay that it happens, because all we need the joint to do is rotate along perfectly one axis, right? Like for the leg, I just need the knee to rotate perfectly along whatever that axis is, right? The other two are fine.
So where mine was like off, so it wouldn't go up, it would go like,
That'd be something we need to fix. Yeah,
yeah.
that means something we need to fix. Okay, I'm over today, and I want to make sure that everyone is aware of what our homework assignment is this week. So your job this week is to go in and complete the skeleton and the hands, okay? So I didn't put the hand stuff in the diagram because I just didn't have enough room, right? I mean, there's a lot of joints in each of the knuckles. It's the exact same concepts and ideas, though. Get your skeleton done first before you do the bind, okay? Question? Yeah? Just turn it in rigged. Yeah, just turn it in bound. You don't need to do a render because there's nothing to render. This is just really kind of an understanding of the process, okay? If you go back to the assignment sheet in the week 6 module on Canvas, okay? Yeah, so please just make sure that everything, fingers, arms, and legs, okay? Bind the skeleton, and then of course adjust the skin weights, the paint weights, to make sure you're getting the proper deformation. This is going to involve touching every single joint and rotating it to see how that joint is influencing the verts around it. It's a process. It'll take you probably 45 minutes to do that, okay? So make sure you budget your time effectively, okay? Yes, sir?
So this week you just would like to see the skeleton set up?
The skeleton and it bound to the rig, and the mesh, excuse me.
Yes.
Yep.
What about animating?
If you want to animate, I say go crazy, man. Yeah. That's a great way of testing to see if the paint weights, the vertex weights, are working correctly.
Before you leave, help me with this really.
Yeah.
For some reason, I can't seem to view this backdrop item from the front.
Hit the O key. Drawing and control. This overlay is off. There it is. Yep. All right. Any other questions? Yep. I'll see you guys next week.